Hi, my name is Uriel and I am the creator of the program Micrometry. Micrometry is a Python-based software that is oriented towards helping in the process of taking measurements in live views of the microscope. For Micrometry to work, you need to have Python installed, and you also need to have access to a camera that is mounted in your microscope that can be perceived by your laptop as a webcam. There's multiple ways to do this, and I encourage you to visit the previous tutorial where we dive a little bit into how you can access that technology. One of the easiest ways, and cheapest probably, is to get a software called DroidCam, where you can modify the webcam that comes with the phone and then figure out how to mount it on top of the eyepiece of your microscopes. So micrometry is particularly useful when you need to take measurements that are something different than straight lines. However, one of the things that is particularly important these days is the ability of also gathering big amounts of data in order to create datasets for machine learning implementations. And that is exactly what we're going to be talking about today. The latest update of Micrometry incorporates Micrometry Datasets. This submodule in here that actually allows us to create datasets in a way that is optimized to deal with live specimens in the microscope. Before we continue, I also want to highlight the use of the submodule in Python called OpenCV. OpenCV is a very powerful library in Python that allows us to implement some algorithms in object detection. And here we can see one of them. This is a form of motion detection algorithm, and the effect of slicing through the copepod that we see here in live view is given by the up and downs in the z-axis of our stereoscope, of our microscope. So it is a powerful tool. Let's start by first downloading Micrometry. Let's go to the top right corner and let's click in this green button and click in the copy URL to clipboard. I'm going to copy this and I'm going to take it into my folder. I created this folder in my desktop and I want to download and place Micrometry here. So I'm going to press Ctrl L in Windows to access the path, and here I'm going to type CMD to open the terminal. Then I am going to access what is known as Git. For those of you that are not familiar with Git, Git is a version control system that is connected directly to GitHub. So I can clone repositories using a secure connection, and that is exactly what I'm going to do. I'm going to type git clone. Oops, there it is. So I'm going to type git clone and then making sure that I still have the link that I copied from GitHub in the clipboard. I'm going to right click. Once I'm there, I'm going to press enter and the program will download the software. Notice that the program is quite light, even with the new extension of datasets, so it shouldn't take too long. Now that we have Micrometry, it's time to use it. The three folders, examples, measure curves, and measure lines, are part of the original tutorial, so I'm not going to go through them. But today I'm going to show you how to install a virtual environment, because I recently created the markdown document for it. So I think it would be also beneficial to show you how to install it from scratch. So if you have Python installed already in your computer, the only requirements for you to run Micrometry is to install the sublibraries OpenCV and Pygame. Pygame is used to load the GUI elements, the buttons, and the display interface, and OpenCV is the submodule that helps us use the object detection algorithms. OpenCV is a pretty powerful tool. The most important script, which is actually the script that you're going to need to run in your computer, is called main.py. But you will notice that if I click on it, in my case, it doesn't open. And the reason why is because my version of Python is being handled inside of a virtual environment that has been created by a program called Anaconda. So let me guide you through the different steps of how to create an environment. The first thing that we need to make sure to have is Anaconda. If we go to the browser, we can search in here the Anaconda. And Anaconda is what is known as an environment manager. What it does is to control the installation of multiple versions of Python, and for that matter, other programming languages, so that they don't conflict between projects. Sometimes you need very specific versions of certain sublibraries that would conflict between each other when running different projects. Now, the installation is quite straightforward. You just download it and install it in your computer. But there is an important consideration. When you install Anaconda, at some point it's gonna ask you if you want to add Conda to the environment variables, or the path variables of Windows, or you're actually not sure for Mac. And if you say yes, you will be able to open a terminal and then type Conda and read directly from there. However, the developers of Anaconda actually suggest to use the so-called Anaconda prompt, this one right here, which emulates a terminal, but it does it by using all of the infrastructure of Anaconda already integrated in there. So it's really up to you. And to be honest, it may not make a lot of difference. Once you have it installed, however, you're gonna be able to access the terminal and you will be able to be in the base environment. So let's go to Micrometry now. And here in the GitHub page, you have a series of instructions on how to create it. I'm simply gonna copy this. I'm gonna go to the main Micrometry folder. And in here, I'm gonna open the terminal. The reason why I do this is because I need to use a special file that is called requirements. If I open the directory, you will see it highlighted right here. Requirements, let me show it to you, is a container that has instructions on what elements we need to install. You can see here that the program will create a new environment called Micrometry-emp. You can change it if you want, and it's gonna download these dependencies or sublibraries, including the Python library, from these channels. Is where to find them on the internet. So let's run this. Here I need to make sure that I still have access to the clipboard element that I just copied, and I right click on it. Let me fix those extra spaces, and then I can press enter. After a while, how long it depends really on how good your internet is and how much processing power your machine has, but after a while you're gonna end up with a new environment. And once we have it, we can run Micrometry right away. Okay, so for me it took around 5 minutes in the time in which it had to find OpenCV. Probably that's the library that takes the longest to find, but then it gives us instructions on how to activate and deactivate our environment. So let me show you what we can do with this. First, I'm gonna change directory and I'm gonna enter datasets. Remember, we are in the main folder of Micrometry. Once we are in here, the files that we can see here include, among other things, the script called main.py. This is the most important script you're gonna use. First of all, we need to activate the environment that we just created. So we're gonna type conda activate, and then we're gonna type Micrometry-emp. Okay, so now that we are inside of the environment, you can tell because of this tiny bubble on the left that says Micrometry-emp, we can type Python followed by space, and remember, we always open main.py. Then we're gonna add a space, and then we're gonna add flags. These flags will specify from the user how we want to run the program. In the previous tutorial, we discussed how to access your webcam. Now, the flag for this is camera index. Here we can use a number where the default is 0. So you don't specify anything and you just try to run the program, that is the index that it's gonna use. However, if I try to run it as is with the index 0, I'm gonna get an error. And the reason why is because I'm currently using that webcam to record this video. So I need to access my other webcams, and I can do it with other numbers. The numbers that I have here, I figure out by basically plugging and unplugging the different cameras, trying with different values. And there's usually 2 or 3, so the amount of time that it takes to do this process way overweights a fancier technique to try to figure it out otherwise. So the other element that we can add with another couple dash is the resolution. And this is a new attribute that wasn't present in the previous versions of curves and lines in Micrometry. Resolution is gonna rescale the dimensions of your camera. This is a float value, so it is a decimal value, where 0.6 represents 60% of the original resolution. In my case, I'm gonna use the number 1. So at this point, I'm ready to connect my webcam with my microscope. After pressing enter and waiting for a little bit, now the camera will open in my screen. So here I'm gonna zoom into the sample that I have placed just from a drop of water that I took from a pond. And here we have our first view. Okay, and here I finally found a sample that I feel happy photographing. So in the top left corner, you will see 4 buttons. The first button in green is going to allow me to start making selections, box selections that is, that will help me take a sub area of this view and save it as a photograph. So that is effectively the core of the program. The other one is the freeze button. So if I press on that, the camera stops updating the view that it gives me. It's still running, but it's not updating it, so that I can take the measurements with more time, because sometimes there are some specimens that are rather fast. To unpause it, I can click again in this button, and that will bring me back the live view. The edge mode that we talked a little bit about at the beginning of this video allows me to identify the movement that is happening against the initial view or frames when the program started running for the first time. So it basically compares which pixels have changed against the original background, and this is particularly useful when working with static scenes like microscopes. I'm going to bring the view back, and then I'm going to talk about the last element here. Set prefix will allow me to type the name of a particular tag or label for my machine learning dataset. As you may already feel familiar with, the datasets for training machine learning algorithms rely on the proper labeling of the samples. So you are creating a model that categorizes among different organisms by models based on object detection and image recognition and segmentation, then it is important that you use the same labels for the things that are categorically the same. So the way that we address this is by setting a prefix. However, this is not the only way to navigate the different labeling. So let's click first on the select tool. A shortcut to click select is to press the letter S in the keyboard, and that will automatically hide everything else in the view so that you have total control on your scene, and then you can move around. There was a really interesting guy that was just crawling around over here. So I really want to take a photo of that one, but I'm not gonna lose a lot of time here. Once I am in the selection mode, you will notice that the freeze button is gone. So the shortcut for using the freezing mode is the spacebar. So you can just use it whenever you find something that is starting to walk away. Okay, I see a sample over there that is moving rather fast. So I'm gonna try to keep it in my view. And once I have it where I want it, I'm gonna press a spacebar. Hopefully there will be room for better photos of this organism later. So here I'm still inside of the selection tool. So I can just left click once, and then I can drag my mouse until I have covered the area in which my organism is located. The closer the better, right? Because otherwise we are just sampling empty pixels. So something interesting that has been added to this particular selection box is the ability of moving in the 4 cardinal directions to expand the view. And so that was a choice based on suggestions on how the program was a little hard to get on the corner sometimes. So this is a nice attribute. So I'm happy with this selection. So if I'm unhappy with this selection, I can press escape, and then I can press S again, and then I can try to redo the mapping of the image. Once I'm done, I can press with the left button of my mouse once more, and then you will notice that the text prefix shows down here at the bottom. I can add the label, and this is going to be my species 1. I'm going to press enter, and then the sample has been added. Where does the data go? So if we go back to the datasets folder, you will see now that a new folder has been created. This folder contains now a subfolder with the name of the label that I just added. And in here you should find the image of the sample that you just took. Notice that there is room for a lot of samples, and every sample that you create is going to have its number updated here out of 6 digits sequentially. So you have enough room to take millions of photographs of specimens. If I want to go back now to live mode, I can press spacebar again, and that is going to take me back to the original view. And that's pretty much it. Soon I will update the newest version of this program that also gives the tool to transform the images into NumPy arrays to be able to import them directly into PyTorch and TensorFlow.